Hello! Welcome to week 6, guys. We have 2 weeks left. 2 weeks, because this third week that we'll technically we have 3 weeks, but I'm doing new content this week, new content next week, and then that following week I'm giving you a makeup week. So stay strong. We're almost there. If you need to catch up, now's the time. So please make sure you're working on that, communicating with me, getting all that done. It is so crucial you pass this semester, right? Like, I don't want you to have to retake geometry, and it is a graduation requirement. So it is important to make sure that you're ending this quarter with a C or higher. You need to make sure that happens. That way, you don't have to retake the geometry test. Like, if you accidentally fail this quarter, they're going to make you retake that test, and I don't want that to happen. So please, please, please reach out to me this week if you need some help, because we're in that final stretch. We're going to spend this week talking about a topic from earlier this year. If you all remember, we did trigonometry, and I wasn't super happy with the scores of those tests because trigonometry to me is not something that was difficult. It was actually very, very simple. I think a lot of you overthought it, though. You put too much into it and made it so much more complicated than it had to be. So we're going to spend this week just reviewing it. I don't have new notes for you. This video is serving as just kind of a guide to show you how to do it. I don't need you to turn it in, but I still suggest those of you that don't understand trig, watch it, because Algebra 2, you're going to need trigonometry. It is super, super important. It will come back to bite you if you do not know how to do SOHCAHTOA. And I'm telling you right now, if you walk into a pre-calculus class in a couple of years with me and you still don't know trigonometry, I will be so disappointed with you. I will send you right out that door and tell you to go find a new math class, because I can't have you in my class if you don't know trigonometry, and you can't go to Algebra 2 without knowing trigonometry, because your teacher will come back and yell at me. So we're going to fix that. So let's jump into it then. So again, in case you don't remember, what is trigonometry? Why? What is this? What is it used for? Trigonometry is the study of triangles, right? And specifically what we did, and I should be writing with a different color so it doesn't all blend in. Well, let me fix that. Specifically, what we're doing is the study of right triangles, right? Because that's our focus. We will focus on other triangles later on down the road, but for now we're focusing on right triangles. And what we talked about is this phrase. I'm going to jump right down here. SOHCAHTOA. The reason this phrase is super important is it tells us something. The first letter points us to which trig function we're talking about. Sine, cosine, tangent. The second two letters tell us what the ratio is. The ratio of sine is the opposite side over the hypotenuse. The ratio of cosine is the adjacent side of the triangle over the hypotenuse. And the tangent is the opposite side over the adjacent side. So we know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So with that, I can then go in and solve some of these problems. In fact, let's go back up here. Ooh, that's not what I meant. Let's go back up here and look at these ones that I kind of skipped over. I'm sorry, I totally didn't mean to do what I just did. Okay, so it says find the sine of A. Well, if we look over here at A, capital A, let's label some sides in relation to that. Well, the one side that you can always label no matter what, that will never change, is whatever's across from the 90 has to be the hypotenuse. Every single time. That won't change. What does change is the opposite and the adjacent. In this case, since I'm looking at the letter A, the opposite is going to be all the way over here, which is little a. And the adjacent to A is little b. Okay, so we then can say, well, the sine of A, since sine is opposite over hypotenuse, the sine is going to be little a over little c. Little a is opposite of A, c is the hypotenuse. I'm going to come back to the b in just a second. When I do cosine of A, cosine is adjacent over hypotenuse. Well, the adjacent is b, and the hypotenuse is still c. Oop, that's not the right spot. Okay, and tangent is opposite over adjacent. So the opposite of A is little a, the adjacent to A is b, so tangent of A will be little a over little b. So if I change this, if I switch and just go and focus on B being my point of reference, my reference angle, well, the hypotenuse is still going to be C. That doesn't change, right? That's still going to stay that. But now the opposite of B is little b, and the adjacent to b is little a. So you can see that it causes the opposite and the adjacent to switch. So it's just going to switch a few things here. Sine is still opposite over hypotenuse. Well, the opposite of b is little b, and the hypotenuse is still c. Cosine is going to be adjacent over hypotenuse. The adjacent is little a, and the hypotenuse of b is still c. And tangent of b, the opposite of b is little b, and the adjacent of b is little a, so it's going to be b over a. You can see some patterns that happen here. Notice that here, the bottom, the denominator stayed the same, but the top letter just switched. Same thing happened here, and even further, you can see that the sine of a became the cosine of b, and the cosine of b became the sine of a. That is an important thing to know. Whenever a and b add up to make 90, then the cosine of a will equal the sine of b, and the sine of b will equal the cosine of a. That's called the complements theorem that we talked about. So that is important to know. So let's bring this down then and look at a couple examples. This first one says find the sine of a, the cosine of a, the tangent of a, the sine of c, the cosine of c, the tangent of c. So we're going to do those separately. Let's start by doing the a's, right? So we're going to circle a and then label everything. Across from the 90 is my hypotenuse. Across from a, the one that's not touching a, is the opposite, which is 5. And the other one is the adjacent. So I can then fill this in. The sine of a, sine is O over h. O is 5 and h is 13. So we're going to have 5 over 13. Do check. Does this simplify? In this case, no. So we would leave it like that. Cosine is a over h. Well, since cosine is a over h, we do 12 over 13. And last, tangent of a is opposite over adjacent. Opposite is 5. Adjacent is 12, so we have 5 over 12. Again, none of those simplify, so we don't worry about it. Now we can do c, and there's two ways you could do it. You could do c by switching the letters, but you could also know the patterns. If you know the patterns, you could figure it out too. Let me start by switching the letters, and then we'll talk about the patterns after, right? So actually, you know what? Let's talk about the patterns first, and then I'll show you the letters, right? We said that what was important is that if a and c are complementary, which in this case, because they come from the same right triangle, they have to be, well, then their sines are equal to their cosines, the opposite. So the sine of a is 5 over 13. That means the cosine of c is 5 over 13. And since the cosine of a is 12 over 13, the sine of c is 12 over 13. So they just switch. This goes to here, this goes to here. Notice what happened with tangent up here. Tangent was a over b, but tangent of b was b over a. It's just a reciprocal. So if this tangent is 5 over 12, then the tangent of c is 12 over 5. And we could check that. We're focused on c. My hypotenuse is still 13, but now the opposite of c is 12, and the adjacent to c is 5. So let's check this. Sine of c is opposite over hypotenuse, 12 over 13, 12 over 13. That's correct. The cosine is adjacent over hypotenuse, 5 over 13, 5 over 13. That's correct. And last is tangent is opposite over adjacent. The opposite is 12. The adjacent is 5. 12 over 5. 12 over 5 is what we wrote. That's it. So this next one, I put this one on here as well just to show, because I think that's pretty easy. Once you get that, that's not hard. The problem that we run into in this one is you look at it and you say, oh no, they didn't put a hypotenuse here. They left it off, right? So I saw some people when they did this, they said, oh, okay, well, great. We're just going to use c as our letter and move on. Absolutely not. You know how to find that hypotenuse, right? If you're missing one side of a right triangle, well, then we would call this little a, little b, and little c, and use a squared plus b squared equals c squared. So 9 squared plus 12 squared equals c squared. We get 81 plus 144 equals c squared. Add that together, I got 5. I got 2 with a carry the 1, 2. 225 equals c squared. And if you square root this, you would get 15 equals c. So now I can come over here and replace that c with a 15 and then solve this the same way. Now I am going to do one side of this with you. I'm going to do w with you just so we can talk about something here, right? So we circle our w. The hypotenuse is the one across from the 90, so that's the 15. The opposite is the one across from our circled one, which is 12. and the adjacent is the one touching our circled letter that's not the hypotenuse, so 9. So sine of W, sine is opposite over hypotenuse. The opposite is 12, the hypotenuse is 15, 12 over 15. Does that simplify? Absolutely. You can divide 12 and 15 by 3. So you would divide it by 3 and get 4 over 5. Going on to cosine. Cosine is adjacent over hypotenuse, so we're going to have 9 over 15. And again, it simplifies by 3. 9 divided by 3 is 3. 15 divided by 3 is 5, so we get 3 over 5. And last, the opposite is 12. The adjacent is 9. Opposite over adjacent is going to be 12 over 9. Divide it by the same thing, by 3, we get 4/3. Those would be your answers. Make sure you simplify if you can. You can do sine of x, cosine of x, and tangent of x if you want to check those. All right, so coming down here then, let's go ahead and talk about some of these solve for the missing sides. And I'm not going to do all 4 of those. I'm just going to do a couple. I don't have a scientific calculator that I can display for you on my screen. I have a graphing calculator that I can display those. So we are going to use that. But you have a scientific calculator, so make sure you kind of learn those buttons, get comfortable with those buttons. Come see me in my office hours if you need help with that, because I can walk you through how to do it. First thing we're going to do then is they give us one of these angles. That is what we call our angle of reference. So I'm going to circle whatever angle they gave us. Then label the 3 sides. So across from the 90 is hypotenuse. The one across from my angle of reference is opposite, which means the missing side is adjacent. Your circled angle should always touch A and H. It should never touch the O. If you circled something and it's touching the O, you screwed something up. So then what I look at here is I say, okay, well, one of those things is irrelevant to this problem. In this case, it's the A. Notice how the A doesn't have an X. It doesn't have a number. It's irrelevant. I don't want to use it. So what I'm left with is an O and an H. So I think about SOHCAHTOA. SOHCAHTOA. We don't worry about the first letter. That just tells us which trig function we're using. We worry about these second 2 letters. Which one has an O and an H? Well, that's going to be the sine function. So what I use here is that the sine is equal to O over H. So remember, what we do here is we put next to sine the angle. So this is going to be sine of 28. And it's equal to the opposite side, x, over the hypotenuse of 19. And we're going to add one extra thing here. We're going to put sine of 28 over 1. Because what we're going to do is solve this by cross-multiplying and then dividing if we have to, and then solving. So I cross-multiply here. X times 1 is x. Sine of 28 times 19, well, I don't have that available to me right now, but we can just write it out. Sine of 28 times 19. And in this case, if there was something in front of the x, you would divide. There is nothing in front of x, so you don't have to divide. We just got to put that in our calculator now. So sine of 28 times 19. So in your calculator, you would type 28, press sine, get that decimal, multiply by 19. In a graphing calculator, we're not going to do that. I'm going to put sine first. So I'm going to get sine of 28 and hit enter. Now, if you did this in your calculator already, you would notice that this is not the right number. You would have a different number than me because I made a mistake. If you actually have the same number, you also made a mistake. We have to make sure our calculator is in degree modes. Mine is currently in radians, so I'm going to switch it over to degrees. On the scientific calculator, there's a button that says DRG. You need to find that DRG button and press it. So going back into this then. Sine of 28, so you would press 28 sine. I'm going to press sine of 28 and hit enter. And I get 0.469, which is the correct one. Then I said I wanted to multiply this by some number that I forgot, by 19. So I'm going to take that decimal, multiply by 19, and press enter. And I get 8.9199, so I could round this to 8.9. I said tenths, right? Yep, so we're going to round it to 8.9. So x equals 8.9, and that would be the length of that missing side. So let's look at one more just to clarify one other thing. Hold on. None of those are going to do the thing that I want them to do. I didn't pick out enough good examples. Go up to this homework. Go up here. Yeah, I'm going to use this one instead. So actually, let me just do it the whole way so it looks nice. I'm going to use number 7 instead. Copy, paste. Bear with me. Okay, so I'm going to look at this one. so first thing we're going to do is label our sides, right? So we circle our angle of reference. In this case, it's a 72. We go here. Across from there is my hypotenuse. I don't want all of you showing up. Stop it. You stop it right now. Go away, go away, go away. You gotta make sound effects when you erase things. It makes it more fun. Okay, so we know that across from our 90 is my hypotenuse. Across from the circled angle is the opposite, which means the one touching the circled is adjacent again. If the opposite is touching the circled angle, you did it wrong. A and H need to touch it. So figure out which one you want to cross out. In this case, the hypotenuse has no information. So I have A and O, which tells me that we're going to use tangent because it's got O and A after it. So the tangent of theta is equal to the opposite divided by the adjacent. Again, theta is 72, so I'll put tangent of 72 equals opposite 25 over the adjacent x. We'll add our 1 underneath our trig function and cross multiply. Well, tangent of 72 times x is going to give me tangent 72, and then we'll multiply the x in the beginning. Remember, tangent of 72, sine of 28, whatever that is, has to stay together as one piece. And then on the other side, 1 times 25 is just 25. So this is one of those ones where you do have to do division at the end. If I want to solve for x, I'm going to have to divide by the tangent of 72. The main mistake I always saw with that is people would be like, oh, I've got sine of 50. Great, I'll divide by 50 and cancel. Absolutely not. Sine of 50 and 50 are different by a lot. Sine of 50 is a decimal, like 0.4 something 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 small. 50 is 49.5 times, like 49.5 bigger, right? That's way bigger. So please make sure that you're not doing this. You're dividing like that. So I divide both sides by tangent of 72. This cancels, and now I have x is equal to whatever 25 divided by the tangent of 72 is. So again, scientific calculator is going to be a little bit harder to type that in. What you're going to do is you're going to type 25, press the divide button, type 72 first, press the tangent button, and then press equals. Don't touch equals anywhere in between that. On mine, 25 divided by tangent of 72. So let's find the tangent of 72 first. Tangent of 72, I got 3.077, right? And then I'm going to take 25 and divide it by that answer. So I'm going to press second and then answer. So take 25, divide it by that, and you should get 8. We said round to the nearest 10, so 8.1 would be our solution here. So x is equal to 8.1. Done. Cool, cool, great. Let's go ahead and look then at these ones. I think these ones are a little bit easier. When they ask you to find a missing angle, right? So they gave me, let's do this one because we haven't done a cosine yet. They gave me an angle of reference in here. So I circle my angle of reference. In this case, angle of reference is x. I'm looking for it. So we label everything still the same. Across from the 90 is hypotenuse. The x that I circled goes across to opposite, meaning the one touching the x is adjacent. In this case, the one that I don't need is the opposite. So using my SOHCAHTOA, I can see that this one's going to be a cosine function because I have a and h. That looks like can. I meant to type right, ka. So ka. We have a and h. So the cosine of theta is equal to the adjacent divided by the hypotenuse. Well, in this problem, I don't know theta. So I'm going to put the cosine of x is equal to the adjacent 8 over the hypotenuse 11. This kind of looks like what we did at the very beginning of this video where you set up the ratio. The problem is that we actually want to solve for x now. So to do that, you have to use the inverse of cosine. So what we do is I leave the x where it is, but I move the cosine to the other side and make it cosine -1. And take the cosine inverse of 8 over 11. So when I do that, for you, what you're going to type in is you're going to put 8 over 11, divide by 11, get that decimal, or 8 fraction 11, however you want to do it. I'm going to press mine first, but then you press second cosine. That's the same as this calculator. You see I press second and then cosine, and it gives me this inverse cosine. Like I said, you would have to have done 8 divided by 11 already, and then press second cosine, and it will do it for you. 8 over 11. There we go. So when I do that, I get 43.3. It said to round to the nearest tenth, so we'll stop at 43.3. So that's going to be our answer, 43.3 degrees. Boom, 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 done. So that's really your major things you've got to pick up. If x is one of the sides on the outside, you're going to do a cross multiplication problem that may have division. If x is on the inside, you're using inverse. Those are it. Those are the two things. Like I said, I just felt like last time a lot of people overthought this and didn't let them get the best of them, essentially, because it's really not too bad once you know what you're doing. So hopefully that helps a little bit with this week's homework. So if you need help, please come see me. Talk to y'all later.